Welcome, everyone. Thank you so much for joining us. We're starting right away here as we get people logging in. I'm Jeff Boyle with Vintri Technologies. I'll be your host for today. We've got a jam-packed agenda that we're going to try to get through as much information as possible for you. And we've also got some information for you in the files on the right-hand side. I'm going to jump over and introduce our panel today. So, as I mentioned, Jeff Boyle here with Vintri. We also have Arnaud with ReVision, and we've got Alex with VEERUM. So the three of us are going to attempt to kind of break down the so what behind material data and share with you what you can take accurate, accessible, and traceable material data and where it can go and the value and benefit of that. So really quickly, what I'd like to do is give ReVision and VEERUM their proper introductions here. So I've got right now, apologize for the reading, but so I've got ReVision is a management consulting company focused on creating strategic and measurable value for owner-operators by unlocking the power of their asset information. Leveraging accepted industry standards, practices, and our deep domain knowledge, we help define and implement the solutions for our customers to improve their safety and regulatory compliance, improve capital project and handover performance, and drive ongoing operational efficiency gains. So that's ReVision, and that's our guest, Arnaud. He will be speaking in just a second here. And then we have VEERUM. VEERUM is a SaaS provider that applies digital twin technology to asset ownership, helping clients build and maintain a better world. VEERUM's cloud-hosted asset information visualization platform aggregates valuable asset information in the context of a 3D reality model, enabling data transparency across the entire asset lifecycle, improving cost, schedule, and safety performance. So with that, I'm going to bring up our first guest and get his slide going.
Hi, thank you very much, Jeff, and welcome to the webinar. My name is Arnaud. I'm a partner with ReVisionz for the last 3 years and been working in asset information management industry for the last 15. I have a background on the IT side as an enterprise solution information architect with IBM Global Services, as well as a stint as an IT manager with a local startup refinery in the Calgary area. My focus is on implementing asset information management systems for our customers, and my passion is driving innovation and value for our customers. As you can see, we've been around since 2001, and we sit at the center of the ET, the IT, and the OT world of operations, maintenance, engineering, information, and information technology. If we move to the next slide. So I was asked to provide a kind of a point of view on common current practices as well as the potential future. So today, if you look at the slide that's on your screen right now and the life cycle that's at the bottom, capital projects, as an owner-operator builds a project, goes through the traditional stages of concept select, detailed design, construction, into RFO during that 1 to 5 year greenfield project, depending on the size of the asset. At which point in time that asset is handed over to the owner, and then that owner is maintaining that asset for the next 20 to 50 years. So based on today's kind of document-centered practices, if you follow the blue line as it moves from left and then up the slope, during the project, the engineering companies, the manufacturers, all the participants of the project create a huge amount of information wealth inside that project. And they need that in order to properly design, construct, and turn that asset over to the owner. Unfortunately, and this is the downward slope, the brown line, most EPC contracts today do not require access to that information during the project, and also request that information as documents at the end of that project, resulting in the EPCs and other vendors taking all that great information that they had, converting it to documents, and handing that off to the owner. So what? Why does that matter? Well, if you follow from the bottom of that brown line up, Once you go into the ready for operations, the commissioning, startup, completions, activities for that facility or for that pipeline, there's an operations and maintenance group inside the owner that has to continuously extract all that data from documents. They try to recreate all that information in order to populate their operations and maintenance systems in order to confirm that they've met the regulatory compliance requirements, etc. And there's a lot of rework that's introduced by that. Plus, a lot of that content, because they start before the project is complete, is done with out-of-date or incomplete information. So why does that matter? Well, it delays the curation of that information in those operations and maintenance systems. It introduces data quality issues into those operations and maintenance systems that the operations team then has to address over the life of the facility. And it creates a net value loss to the owner of all that intelligent information that was available that they've chosen to throw away and discard as part of handover. So as you follow from that first big decline, the kind of the yellowish line up, that's all the work that the owner operator has to do to recreate information that in many cases already existed in the project. Then as they start a new project.
Arno, sorry, I apologize. Can you just speak up a little bit? We've got quite a few messages coming in that individuals are struggling to hear you. So if you could just speak up as much as you can for them. They're interested, they just can't hear you.
I apologize for that. I'll try to speak a little louder. So as I was saying, as the owner has taken control of that asset, they've started it up, they're operating it, they continue to have to increase and improve that information and align it with their O&M systems. Then you get a new project starting up, and that's that slope up again, where instead of using or reusing existing engineering information and other information, the EPC companies and manufacturers have to recreate all that information from the documents before they can even start creating the new designs or making the modifications to that facility or that pipeline. So there's a net cost to that, and then there's the ongoing enhancement. Then unfortunately, again, the information is turned over as documents back to the owner operator, and the cycle starts again. So those are some of the common document-centered practices. Now, the revisions point of view is that there's a different way of doing things, and that's what this webinar is about as well. If instead of doing it the old way, we started with the end in mind, if instead we started leveraging the operations and maintenance teams and defining those requirements, if those EPC contracts and those contracts with those manufacturers required that the data be turned over to the owner, not only at handover, but even during the project, then during the project, that information is available for quality assurance. It's information, you can use it for visualize current project status. And those are some of the things we'll see later on the webinar. But also that information is available to the owner operators, to populate the CMMS systems, to populate the DCS systems, to populate the tag in, tag out systems, all those operation systems working off real data and able to monitor changes to that data so that the information in those systems is as good as possible. Additionally, as you move forward, there's, you reduce the cost of recreating that information as you start a new project. That information already exists, so you don't have to recreate it and walk down the line and create that initial starting point. So over time, you continuously to increase that information asset. And what you do is you remove that content debt that you incur every time you convert data to document. The side benefit of that as well is that you can leverage that data through the cross-functional teams by aligning all the identifiers across those systems, making future integration simpler. And that's what we'll see in the VEERUM demonstration, where we can pull the digital twin, the reality model together with the tag, and then pull the work orders into it. So by designing it with the end in mind, you can enable all those things from the beginning rather than trying to back into that with a lot of rework and complexity during the operations. Why does that matter? You reduce capital costs, you improve efficiency, you improve your data, you effectively allow yourself to remove the barrier to entry to things like risk-based maintenance or condition-based maintenance, or using that information in analytics and KPIs in order to prove the efficiency of your plant, all of which, if you do that successfully, can increase your revenue. So that's basically the main spiel between where we are today, document centric, and the potential that exists if we were to move to a data centric world and we start leveraging data not only in the project, supporting regulatory compliance requirements and project improvements, but into operations where we can continue to improve how that asset is used and how we leverage that data for the next 20 to 50 years. There's a couple of bullets at the bottom talking about the potential savings to owners. There's been many case studies. Be happy to talk about that at a future date. But at this point in time, I just wanted to hand the slide back to Jeff to talk about the Vintri solution.
To the point that was just made, there's this huge value of transferring the data. And we actually have one of our major customers that recently has really brought this up as a topic that it was actually a unexpected advantage. So Vintri has always been helping their owner-operator partners with making sure that all of the supplier data comes in, it's consolidated, it's then put into a single ledger so that we can audit it with our proprietary algorithms, check it for engineering conformance, check it for traceability, all that stuff. Then we make it available to anyone and everyone in either a flat file format like an Excel spreadsheet, which, yeah, is simple, but it's easy to upload into other formats, or our platform core is API centric, so it's designed to go and fit into other programs that can pull from it. So finally, we're starting to get more and more feedback from our customers that they're realizing the benefit not just of having accurate and accessible data, but also what was just discussed, they're not losing that information as they transfer it from one solution to the next. And we're very fortunate that we've known VEERUM for quite some time, but there's a lot more customers starting to poke around and ask, well, how would you transfer your information into a platform like VEERUM? How does it go there? So based off of the value that Arna was just talking about, that's our goal here, is to quickly show you the data that, well, our lifespan visual that's up right now quite relevantly reflects the visual that was just there. But we're going to show how the data can go from the full lifespan, so from manufacturing through construction and then over into operations. And for us, in this exact example, Alex is going to be able to show in stage 8 the data visualization of all this information coming in, as well as realistically on their side they can show it in the manufacturing as well, and then in the final resting place of having this usable data in many different formats. For some of you on the audience, there could be an open text logo here as well, because we're working with that team to make sure that all those documents can be accessible in all formats. So with that, I'm going to just take us through a slab or a coil right through to the welded asset and show that to you through actually our platform. So we've got just a quick glimpse of the platform, and we've got our different asset types. For this situation, we're going to go into just our steel potential assets. I'll cheat even further and just show us potential assets that are already available. So we've got a summary of our steel that we looked up, and we've got our different assets. What we can look for from here is our related assets. So from that steel, we're going to go into the pipe and show it at a quick glance related to the steel, but also we can go into the direct asset. In here, we have the summary of the asset. We have its pipe information. We have its coating. It's part of a double joint, so we'll show that in a second. We have its ability to export, like we said, as it was described. It can go into that PDF format, which of course would lose so much valuable data, but it can also go in the Excel flat file, or it can go be pulled directly via API. And we have the from a related asset standpoint, now that we're in the individual pipe, we also have its double joint that it's a part of. We have its steel raw data that belongs to it, as well as we have the weld for it. So quickly, as I catch my breath, because of course the demo can never go perfectly right, I want to show quickly on the steel side, we have both the actual heat and then the pipe details for that. So in there, in a quick view, while I'm still in the pipe, I can see my product details, my chemical comp, I can see my tensile, I can see my impact, my drop weight, my hardness, all that different stuff. But I can also, if I want to see it at a glance while I'm in the asset, I can actually go into that specific asset. So I can dive into the MTR data and get right down to the micro. And of course, what we're talking about for the overall example is not having to get into this much detail and not having to put this much information into a system like VEERUM, but have it over here in Vintri Core so that it's accessible. But realistically, you can have a few key tags within a system like VEERUM that link back to all of this critical micro information. So within the actual asset, again, we've got the digital MTR broken down. It's searchable by whatever we need to find at the different times. And then we go backwards, back up into the asset so that we can look at the different information. So at the pipe level, we can, to the point of documents versus data, we can see the, we've got a hydro test, the if there's an NCR to it, the original ITP that belong to the assets that can be mass uploaded, any photos taken, and of course that MTR as well. We can see, go into one more layer, we'll go to the double joint. And on the double joint level, now we've gone from steel, we've gone up to the pup, we've gone up to the double joint. On the double joint, we've still got that pipe information, but now we have the coding information because once it was a double joint, then it got coded. So we've got our coding information. We're not going to move this pipe, so we're not going to show the location map, but any stockpile information, any geospatial information associated to the asset can be associated either in a location chart or overlaid onto just simple a Google Map overlay. Again, we're exportable in any one of these formats. And finally, we'll go one last chance to look at the different assets. And when we look at this asset specifically, we can see the final layer, which, what I said, going from steel, raw coil, right to installed asset, is we want to be able to see the weld. So we can dive into the weld information that put that asset in its place. And so we've got our quick summary. We've got just a summary of what weld log information was available. And then in here, we can have attachments. This has got a photo of the weld, but the inspection test plan, or more pertinent, the weld procedure can be added there. So that's just some of the glimpses of what's available there and how this will all go in. The key to a major component with the Vintri core system is actually the translation of it. So what we have from a translation standpoint is the ability to, just really quickly sharing a different screen, it's going to let me, is the ability to bring in the entire map of all the different supplier data and translate it over into a common data, standardized data model. For all those from the operator standpoint that are saying, well, that's great, you put it into one model like pods or an Esri model, but our organization doesn't work like that, or we have our own nuances. This can translate the micro data into a common data model, but then also translate it into your common data language. So for all that usable data, we make sure we take all the supplier data, we translate it all into one common language so that supplier A, supplier B, supplier C now are giving you usable data in one format. And then you again can translate that further to your nuances, your systems languages, so that you don't have to do the huge change management. And where that goes to then is the ability to have, as I go through many windows linking in there, the ability to provide it in a format that is easily loadable into a data visualization tool such as Alex and VEERUM. So without further ado, I'm going to pass it back over to Alex.
Thank you, Jeff. And if you want to bring the slides back up, that would be great. So yeah, thank you for the introduction and a sort of brief overview as to how we can actually start maintaining data through the asset lifecycle from engineering and construction all the way to handover and operations. And there's one piece that Arnout and Jeff mentioned, and it's all about how do we actually relate information through unique tag IDs so that they can actually be aggregated at scale and brought into the context of a 3D visual model and made accessible to the whole project team. And so, this really starts in the early phases of engineering and construction. And when you're working with some of your different suppliers, whether they are manufacturers or an engineering firm, and actually, helping establish some of those standards from a unique ID and tag management standpoint. And ReVisionz, I'm glad that they're able to join us on the call today. They're a leader, I'd say, in our space in terms of creating those tag registries and really that asset information management system where we can actually link information from various sources of databases, whether they be CAD systems, GIS systems, material traceability systems like Vintri, or content management systems like OpenText, and maintenance management systems like SAP PM or Maximo. And so, really what we're doing is bringing all of that data together, both through unique identifiers and also through user-created objects, and linking them to your 3D CAD model and your reality scans. And so I'll share my screen quickly here just to show you how this looks through a live demonstration of the platform. So I'm assuming you can see my screen right now. This is a pipe skid module, which would be quite typical on a oil and gas project here in Alberta. And what you see here on the right-hand side is your CAD model. Typically, this is what your engineering firm will produce for you, and all of the metadata behind that CAD model is accessible through the platform. So here I've clicked on a particular component, and I've got all of the associated object properties. And so the engineering firm puts together, their description, some of their unique identifiers, the metadata behind the model. And if we actually start thinking about, what with the end in mind and what kind of data model we want to create across our organization, we're able to interrelate different data sets, whether they come from Vintri database or from some field applications, through those unique identifiers like a unique pipe ID or a weld ID. And some of this may already exist within the CAD model, and other sources of information may exist, through a type of spreadsheet or maybe more conventional database. As we start executing our project, we'll start ingesting different scans and survey data from the field. Here you'll see there is a laser scan of this same component. And it's worth noting, as you start handing over this asset from engineering and construction into operations, all of that metadata resides in the model. I think it's quite common across the industry to do our best efforts in maintaining as-built, but maintaining three-dimensional as-built in terms of the CAD model becomes quite difficult and time-consuming because you need to update your CAD model whenever you make a modification from a maintenance or brownfield expansion standpoint. And so by actually translating some of the object properties from your CAD model onto the laser scan, you're able to rescan your facility at periodic intervals and actually maintain a lot of that asset information and really use your laser scan a little bit more as an intelligent three-dimensional as-built model, which can be used for a variety of applications. You'll see here, on some of this piping, we've got some Vintri data as well, some of the material traceability, but data can come from multiple different systems. So, here on these flanges, this particular, client has a different flange management system. So we're also able to bring in, different data from different sources of information. And what's key here is that it's information that resides as data and key value pairs, so that it can be analyzed at scale across your asset. What I'm also most excited to show you guys today is our latest development and feature, which we are calling user-generated objects. So, one way to link all this information is, again, through those unique identifiers, through those, tag IDs. A lot of our clients say, well, Alex, I've got an old facility. It was built in the in the 1900s. We don't have a good CAD model. We do have, two-dimensional asset information in our databases, but it's not linked to any 3D reality. So I'd like to show you a little bit how, you can actually use this laser scan as a, starting point in your three-dimensional as-building process. And so typical process is you do a laser scan, you hire an engineering house to convert this into a Revit model. It might cost you multiple millions of dollars and, about 6 months of time. Why actually go through all that additional step if you can actually use the laser scan as your, three-dimensional XYZ coordinates, and then assign properties and link it to your asset information management system. So what I'll show here is really the ability to create your own, objects and properties within the model. So here I'll essentially create a bounding box around this flow element and isolate this as a particular object. And so I can then create this object and save it. So I can call this flow element. And I can maybe call this category asset information management and add a variety of key value pairs. I think the most important one is, again, that unique tag ID. So I'll do tag 123 just as an example, and I can create and actually save, that particular object so that it can be analyzed and tied into the rest of your asset information management system at scale. So if you have your unique tag ID, you can go through this exercise relatively quickly, and we can use a variety of different object classification and manual methods to do that. And then, query your databases, whether it be, Vintri or an SAP or a Maximo or an OpenText, and actually pull all of the information from those related databases into the model. And so what I'll show here is just a couple other examples. So here we've got a pressure gauge as an example where I've actually pulled some data from an IBM Maximo database, and this is just some work order data. So we've got location of the site, we've got an image which we can view of that specific pressure gauge. We've got some attachments. Maybe this is the original equipment manufacturer manual. Maybe this is a procedure. Maybe this is an inspection test plan. There's all sorts of different documentation we can bring here. And again, this is configurable through a variety of different systems and integrations. Here I've just selected a motor from the drop down, and here I can see some real-time data actually coming in from an OSI Pi system, so historian on top of your SCADA or DCS system. And again, all of these can then be saved as properties so that they can be analyzed at scale through the model. And there's therefore one very automated way of, if you've got a great asset information management system and some existing CAD models, we can link that all together and put it in the context of the reality scan and some 360 images and photos. But if you don't have that same quality of asset information, that doesn't mean you can't get there through your digital journey and your digital initiatives, and starting to link some of this information piece by piece. And I think you'd be amazed by how much you can accomplish in just a couple months' time. So without further ado, I'll stop sharing my screen, and I know we're reaching the 30-minute mark, and maybe open up the floor to some question and answer period.
Perfect. Thank you so much, Alex, for showing that to us real quick. And yeah, we've got some questions in. So for Sakshi, yes, this is recorded and will be available on Vintri's YouTube channel. So you'll be able to. So from a question standpoint, we also have one from Andrew. And the question, if you're not looking in the chat area, is one area we've struggled with in the past is aligning material information data required by TC versus what information required according to industry standard. And then he mentions, which often misses a lot. Yes, Andrew, it does miss a lot. How customizable are the data fields for material items? So from the Vintri core standpoint, it's completely configurable. So it can handle as much or as little information that your suppliers can give. And then we also, I mean, TC specifically, we work with your supply chain group to try to continuously build up from an iterative standpoint the material requests and the data points you're asking for from your suppliers. It is quite an iterative approach though, because we have to get it early in on a project. So it takes its time to cycle through. I can also speak to the fact that I was on API 5L calls all this week, and with PHMSA changes, API is going to be making a lot of changes around a much more robust digital version of MTRs and the material data. That will also potentially help with what you're talking about. But from our standpoint, completely configurable on which data points you collect and which data points you progress, to the point of even on your 4D initiative, we can create extra blank columns so that it just fits the 4D upload. So I hope that answers your questions from a Vintri standpoint. Alex, what about from a VEERUM standpoint?
Yeah, so yeah, really, material information and standards. At the end of the day, I think the most important part is having those conversations up front with your contractors and saying, what are the expectations from the outset. And we work with some organizations on helping establish those expectations, especially more on some of the reality data and the engineering data. But I think there's also a space where ReVisionz does quite a bit of work in terms of actually setting up some of those governance standards and setting up those baselines so that you can actually track against them as you're moving forward. So maybe I'll pass that over to Arnoud as well to provide his perspective.
Thank you. That was a great question. We see this quite a bit, actually. So it always goes back to, what does good look like for you, right? An industry standard is a great starting point, but at the end of the day, you need to define as the owner what your information requirements are. And those information requirements then have to be written into the EPC contract and the supplier contract, so that information is provided. The more alignment you have with the industry standard, the easier it gets. We're members of CFOS, where we're trying to define all the information requirements from a document perspective for standards and tag and equipment classes. But that the owner always has the ability to learn from the previous project. As you have a starting point, you bring it into operations and maintenance. The operations and maintenance team then augments that standard with the information they need, and that gets written into the next contract. So it's not a do or die. You can incrementally build towards that information standard to continuously improve your project performance. And by extension, you can then collect that information and visualize that information in the tools that you use on your project and that you transfer from the project into operations. I hope that answered the question.
It does. Unfortunately, Arnaud, they're still struggling to hear you. So for the next question, if you could maybe throw in a headset, and we'll see if that works better for your next round. If you mute that setup. And apologies to everyone. He's giving great information, so I can hear it. I think you're going to be able to hear it on the recording. So one quick thing that is just something that I wanted to quickly share in order to still just show that this transfer of information can stay within its own systems. Alex brought up a great point, is just one other feature where from a document standpoint, you can have an actual document here, but more importantly, from a standpoint of making sure you have version control. I mentioned open text earlier. We're talking about a lot of data going into the VEERUM system. We find it very important to, instead of have that copy exist in each of the formats, I think there's going to be a major trend for a lot of solutions going down the URL path, so that they can actually just attach the link, and then you can have one common data lake, whether it's Azure, AWS, or whatnot. You can have a common data lake for all of your documents, and then just use these solutions to link it back, and use these solutions to have their specific data, their specific niche, but all play from an ecosystem standpoint and linking back. So I just wanted to quickly show that component of URL versus having copies in each one of these entities. From a next question standpoint, we've got Steven's question. So I see the benefit of VEERUM data sets being able to communicate and transfer between different platforms. Capturing the data sets and information, he knows what he's talking about, is still the issue. Actually gathering all of that data. You can have amazing systems in place, but if no one's capturing it and it's still a manual process, does it get bottlenecked? Yes, 100%. So I think, Stephen, what you're bringing up is just even the need for the collaboration in the industry, right? The collaboration between Vintri, ReVisionz, VEERUM, other organizations that are at the forefront of using new data capture technologies to make sure that we're all talking to each other. We all know how we're going to tag these assets, how we're going to potentially use the SAP commodity code, the unique identifier from the suppliers, other different informations. I know, Arno, you were talking about like the flock identification yesterday. The conversation of knowing what each of those tags are, so that when it comes back to that manual data capture, these systems still know how to link it all back together. But yeah, it's kind of yes, there's still a ton of manual, but there's a lot of features coming out these days of new forms, better forms, LiDAR, geospatial. Well, Alex, I'll let you talk on that. You know it a lot better than I do. You're on mute, Alex.
Thanks, Jeff. I think the answer is twofold, and I think it goes back to Arnout's initial slide. There's so much great information that is captured in that engineering construction phase that when it's handed over to operations, it becomes, let's call it, dehydrated and transformed into documents, and then you're continuously trying to let's call it catch up on that content debt, and then start linking some of that information. So easiest way is you start from the get-go on the engineering side and really start linking that information from day one. But I would say even we're working on legacy facilities that were built in the 1960s, and the ability to link some of that information and capture some of that information has become easier and easier day in, day out. So there's lots of interesting tools, whether it be one, actual data capture on site has become a little bit commoditized, to things like nameplate readers for existing nameplates that are on piece of equipment on site, different sources of natural language processing, and some AI ML data extraction tools which can be used to streamline some of these processes. And then there's a manual link that can be done, but there's a lot we can also do in an automated fashion through different sort of scripts and technological tools. So I know there's also a space that ReVisionz does quite a bit of work in sort of especially linking that asset information management side of things, and then working with VEERUM on how does that link to the 3D model. But maybe Arnott, you can speak a little bit to the AIM side.
Yeah, absolutely. Can you guys hear me okay?
Much better.
Okay.
I can hear you better, so
good. Well, we'll give it a shot. Yeah, 100%. Again, great question that affects both greenfield projects as well as brownfield. Is one of the reasons we're so passionate about using a key identifier and using it consistently throughout your entire systems. So if I can use the tag, if I can link a tag to an equipment ID, and if I can capture information about that equipment, either inside the project and turn over as data, or in operations manually, then all I have to do is continuously improve that piece of data, but is linked through those key identifiers. And through those key identifiers, I can link information from any systems. That way, any functional team can augment that data set, and you can build that data set and reuse it many, many times over time. The more data sources you have, because it's you define and design the equipment, you generate the tag, you order the pumps, and they come in, and then when you construct them, you actually know which serial number is associated with the pump that's installed in the location that's defined by that tag that's on that drawing. So you incrementally build that data set over time. Those key identifiers let you pull it all together. And that's why we're passionate about saying, design with the end in mind, manage your information consistently across the systems, enabling the digital twin in the future.
Perfect, thank you. And I didn't see any comments, but I heard you better, so I hope that worked better for the group. I just wanted to remind, we still have 72 live guests, which is fantastic. Thank you. We're going to wrap this up at the end of the hour, just to try to keep getting questions in. But if you have any other questions, please submit them so we can answer them in real time. Of course, you can email us afterwards, and we'll get the information out to each of our guests. We're available at info@vintritech.com or marketing@vintritech.com. As well, all three of us are available on LinkedIn, so you can go that way. So just looking at this, oh, Jim's just making a comment about great to hear about some of this stuff. So there we go. So Stephen, we've got another question. How long do you usually, Stephen has submitted another question. How long do you usually recommend for timing lifecycle engagement and the amount of time required to initially set up the structure and hierarchy with the customer? So why don't we start with you, Arnaud, and I'll go last.
That's a great question. It depends on where the customer is in the maturity. Typically, we start with initial maturity assessment. Some customers are still in the ad hoc document-centric world, and some customers are further along the path to managing tags, to document relationships, to starting to capture the data. So it really depends on where they are and also what the focus is. That initial engagement is usually, to figure out where people are is 4 to 6 weeks. To come up with the plan, and then we work with them to, if their standards are required, we help them define the standards, what good looks like, because that's a key input into the configuration of that CMMS system or that engineering design tool or the Vintri system about what data needs to be captured. So usually that's going to be a couple of months engagement to get that. One critical deliverable is your turnover handover standard, and that all just depends on where you are, but that falls into that 2 to 3 months to define your vendor document requirements, your engineering document requirements for turnover, and then your data requirements. So that's, I guess, where I would start. It's probably initial 2 to 3 months, and then implementation could take longer depending on the scope and complexity. Turn that back to you, Jeff.
I'll let Alex go.
Yeah, maybe I'll just build on that a little bit. On the AIM side, again, that's part of the reason we work with folks like ReVisionz, who are professionals in this space. Every client's a little bit different in terms of where they're at in that maturity phase. But when it comes down to bringing in the traditional data sets we take in, whether they be CAD models, reality scans, drone captures, we can typically do that in under a week. So it's a very quick time to value, very low friction in terms of implementation, and then it's a journey, and it can be a 3-month journey, 6-month journey in terms of actually linking all that AIMS information, whether it comes in the form of integrating with SAP or CMS system or some of those other enterprise solutions, and then it comes down to really what source of information do you need to actually achieve the desired outcomes, whether it's remote maintenance planning or improved safety and incident management. So it's all about creating something that is fit for purpose and then generating quick wins along the way.
Perfect. And then on our front, to that question, so Stephen, I mean, sooner is better for us when it comes to the supplier. We really try to work with our customers to get a sample template or just even a list of required data out in even your initial RFI. We definitely want it there for the RFP, and within the PO documentation or the material requests. That is the ideal situation. We probably have half of our 45 projects that we get brought on after all of that's already done. So we actually had to build out a data mining division just to deal with the fact that we're going to get some stuff in document form, and that's all it's going to come in. We understand that, especially on the facility side, as we grow out of transmission line. Some of this stuff could have been procured a long time before any of this initiative started. So the key is having these systems as flexible as possible and talking about it as soon as possible. But I can also say that on a couple major projects right now, suppliers are saying, oh yeah, that was written in the requirements of the PO. We just didn't know what we had to do. We didn't realize that wasn't just a PDF. So you get in as early as possible. We've been thrown on a project that was already 60% through pipe production, and we still brought huge value because we take it iteratively, and by the end of that production, they still had more usable data than they've ever had on a project. There's, of course, a lot of bumps in the road when you're joining that late, but realistically, you can't just wait for a perfect situation. You just got to work flexible and make it happen, because we know that most operators, they need an internal business case before they really try to adopt this across the board. So on that first project, to VEERUM's point, yeah, we need a week. Let's give us a week heads up, and we can make something work, because we know that you need those internal business cases to drive this on a larger scale. We've also got from Lorene, good to hear about digitization of assets. Curious about interoperability between systems and how this impacts our requirements, or how they would change for our suppliers. So I know from our standpoint, usually when a major RFP goes out, I get a lot of phone calls from around the world of all the major mills saying, what does this mean? What do we have to do? For our standpoint, we've designed this to just be anyone can use their internal systems. We're not making the suppliers adopt a new system. They just have to be able to put it in a usable format, so a flat file. And for the most part, almost anyone's internal systems can produce a flat file. And then for security, for controls and document controls, of course, they can save it and attach the PDF, so that if their pushback is, well, no, someone might manipulate that table. No, you have it in a PDF and you submit it in your flat file, and then it's in a usable format. So for most pushback we've experienced over our last 6-7 years of being on projects, that's a pretty quick conversation to get past. But there are more solutions coming out, both from us and other members in the ecosystem, that are going to be designed to help these suppliers comply with your data requests. Because you're procuring not just material, you're procuring the data, and you're owed that data. It's just our industry has been moving at such a pace that the value of that data has been a little bit underappreciated. And procurement groups out there, like you are buying the data, it's yours, you deserve it. So it's very easy for you to ask for it. We have 3 Fs in our best practices document that is available to anyone. Format, frequency, fulfillment. Get it in the right format, get it as frequent as possible, because to the point earlier of catching things earlier is going to lower the cost. And then fulfillment, you're owed this data, so it's part of the price to supply on your projects. Alex, or Arnaud, do you want to add to that?
Yeah, maybe I'll, interoperability is something, it's the driving, value proposition we bring to clients from day one. I think there's a lot of work that's already happened around the world that we can leverage from a standards perspective. So our entire platform is built on the building information modeling standards that are set out by the European Union Commission. So BIMs, gained a lot of traction out there. It's all IFC standards, so industry foundation classes. And really that's where we've built, a lot of our, interoperability standards. It's all about, having open ecosystems that are able to talk to each other. Same thing goes more on the geospatial side of things. Again, we follow the Open Geospatial Consortium standards, OGC, and try to always strive to use some of those common standards, from a laser scan format, whether it's have it using UTM coordinates and LAS E57 versus some of the more closed off file formats like Recap as an example. So interoperability lies at the core, and how we sort of address some of that is everything gets converted into point clouds and within a common coordinate system. So your CAD model gets converted into a point cloud, but it still retains all its same properties and information. All your scans from the site retain again their properties. And if you think of all of your physical assets in the field, they all have a single place that they exist within the world, and everything actually has a location attached to it, whether it's a weld or it's a bolt or it's an actual component or a piece of equipment. It all resides within a time and space. And so if you're able to actually link all the information to that space within a coordinate system, then it becomes pretty powerful in terms of what you can do from an interoperability perspective, and really link all your information to the actual assets and the locations in which they live in the world. So really that's what the digital twin kind of means to us, and interoperability is a fundamental principle of this.
That's a great point. Geospatial is the great equalizer. I mean, we were doing a CEBA Foundation webinar yesterday where we were talking about fiber optic leak detection and other scanning solutions for like a boom system over a trench, and we were talking about like a disruptive ILI technology. All of them can overlay if you have the geospatial data where you can make the link back to it. And we get a ton of questions about, like, of course, Vintri gets associated with our barcodes and QR codes, and people go, well, can you read this in 20 years when you do an integrity dig? And you're like, it doesn't matter. The second you put it in the ground and you get a geospatial data linked to that single individual asset, you will always know what's there in the ground based off of standing there and just using the geospatial tag linked to the unique identifier. And so, yeah, great point there. Anything you want to add?
The only add I have, I guess, we look at it 3 different ways from interoperability. Organizations like CFOS or IOGP, GIP 33 and 36, they're driving a common vocabulary for information, so equipment properties, etc., so that when that information is changed, everybody understands what it is. Systems, and it's already demonstrated with Pi that has REST APIs that can be used to integrate data. And then what we're passionate about is you can have the greatest technology, but if your identifiers are misaligned between systems, you have a lot of work to do to try to create cross-references and everything else. So the data needs to be aligned across the systems as well to enable interoperability and to display information inside a reality model based on the ID of that tag or the equipment ID or whatever, the work order ID. But those common identifiers are key and need to be managed and designed to work together.
And that's where we approach the asset-centric data repository versus the relational database, because then with asset-centric, if one tag's not working, but you have suppliers providing other usable tags, you can link on many different levels to make sure that you have that match. Versus the relational, you can hit a roadblock pretty hard, pretty fast. So yes, definitely a good point. We're coming up to the hour here, and I know we had some other questions, but I've still got great questions coming in from the audience, so I'm going to keep going. This one's directly pointed to VEERUM. So what challenges did customers that adopted the VEERUM platform have to navigate? Any continuous improvement efforts to address the challenges?
Yeah, thank you for the question. And yeah, maybe there's a few different things we've heard, and every client is a little bit different. I say, the one piece, where we operate in the, in the construction space quite a bit, and it's no secret that, the level of digital adoption in the construction world is very low. And there's lots of great studies out there that find that, construction remains the second least digitized industry in the world. And, there's multiple fundamental, reasons for that. One is, a sort of, difficulty in adoption. And that's multifaceted. One is, the digital literacy of people, both in the office and in the field, and how do we actually get them, comfortable in using the platform. So, the second part of the question, continuous improvements, really we focused on making our platform, people-centric and customer-centric, and really bringing in some subject matter experts in the industry to make this as easy to use as possible. So, often people get frustrated using, something like, Navisworks or a traditional CAD system, because there's 300 different functionalities, and what sort of buttons do I click to get to the outcome that I want? So, how do you make something very clean and easy to use? And that's part of the reason we made everything, web-based, accessible on a laptop through a traditional web browser with very low bandwidth, so that there's no, real restrictions or limitations in terms of, hey, I need a high-powered workstation, I need, heavy machines. So, that's one piece of it. Second is that sort of culture piece. So, our model is unlimited users, unlimited data within a work scope or within a project scope. And, part of that is also providing access to your contractors. So I think, the more we can bring the contractors involved, and the manufacturers involved, and the fabricators involved, and the owners involved into one common viewing environment, the greater collaboration you can actually drive across each of those parties. Some of the challenges we've found going through that process is that, everyone likes transparency. No one likes too much transparency, especially when you're on the contractor side of things. So when you're executing work, whether it's in the fab yard or on the construction site, I want to be able, as the EPC contractor, I want to be able to address some issues myself before the alerts or, visibility actually gets, provided to the owner. So, we often hit roadblocks on driving adoption on the construction side, mostly because, they don't want the owners to see certain parts of the daily work practice. But again, I think that's a cultural shift that needs to happen. And we're seeing some great, momentum in the industry around collaborative contracting, and, owners and engineering firms and the whole ecosystem working together to really set up, some of those, let's call it, objectives from the outset. So, we're part of what we try to do is, create a system or a story or an objective that really becomes a win-win-win for everyone, so that everyone's invested in the success of the implementation. It doesn't become a, the owner is trying to spy on me, the EPC kind of relationship. It becomes a little bit more collaborative. So those are just a couple of the of examples, and happy to talk about that a little bit more offline.
Perfect. Yeah, you can definitely reach out to Alex on that, and that brings us to our hour mark, and we're not going to go over that. We're still very fortunate. We have 50 guests tuned in right now, so thank you all for taking in this time. We would greatly appreciate any feedback on how we can improve this outside of my terrible copying and pasting, and also what other topics you would like these individuals to come back and chat with us on. Maybe it's a specific area that we talk on the next stage, and not just such a general overview. But thank you everyone for participating. Thank you for joining. This will be made available on the Vintri YouTube channel. And please, if you found it valuable, share, like it on LinkedIn, so we get this out to the network within our industry. Thank you so much, everyone. Have a great day.
Thank you, everyone.